We have seen that the anthocyanin pigment in cabbage can change color with the pH level. Understanding the pH scale can help us figure out how to change the pH level of a solution so we can get the colors we like. pH stands for potential of hydrogen. Hydrogen is the most abundant element. About 75% of the atoms in the universe are hydrogen, since most stars are made of it. Hydrogen is the first element in the periodic table. It is number 1 because it is made of just one minus charged electron, E minus, orbiting around one plus charged proton, P plus. The proton is also called a hydrogen ion. Hydrogen ions are important pieces for the pH scale. Hydrogen is common on Earth since water molecules are made from two hydrogen H attached to one oxygen atom O to make H2O. Hydrogen bonds to oxygen by sharing its electron. Sometimes oxygen keeps an electron and a hydrogen ion sadly falls away. The extra electron makes the oxygen atom minus charged. The remaining team of oxygen and hydrogen are called hydroxide, OH. Since the OH team captured an electron, E minus, it's officially a minus charge hydroxide ion, OH minus. Hydrogen ions, H plus, and hydroxide ions, OH minus, are the two ingredients needed to understand the pH scale. More hydrogen ions, H plus, than hydroxide ions, OH minus, makes an acid. More hydroxide ions than hydrogen ions makes an alkaline. To see how it works, start with a cup of water with 10 water molecules shown. Water is not an acid or an alkali. Water is neutral with a pH level of 7. Breaking the water molecules into hydrogen ions and hydroxide ions does not change the pH level because there is still an equal amount of hydrogen and hydroxide ions. However, if we increase the number of hydroxide ions H plus 10 times to 100 and decrease the number of hydroxide ions OH minus 10 times to 1, then we have an acid with a pH level of 6. Similarly, decreasing the number of hydrogen ions to 1 and increasing the number of hydroxide ions to 100 creates an alkaline with a pH level of 8. For a stronger acid of pH level 5, increase the hydrogen ions another 10 times and decrease the hydroxide ions another 10 times. At that point, we have 10,000 times more hydrogen ions than hydroxide ions. For a stronger alkali with a pH level of 9, we need 10,000 times more hydroxide ions than hydrogen ions. If we continue extending the pH scale, the number of ions becomes huge and difficult to write. We need 14 trillion times more H plus than OH minus for a pH level of 0. We also need 14 trillion times more OH minus than H plus for a pH level of 14. These large numbers are easier to write using scientific notation. The 14 in the exponent also gives us a hint about why the pH scale goes from 0 to 14. Move on to the next lesson that shows how chemical compounds change the pH level by adding more hydrogen or hydroxide ions. For a free lesson plan about color-changing cabbage with self-correcting quizzes, go to oinkidoacademy.com. See you in the future.